students and YouTube learners. This is Dr. Satish Singhal with the looping control structure video number 4. We have quite a few more to go, although last few will be on the design example. I think I might do one short one on flag control and one on nested loops. But this one is very important because we talk about a loop called EOF, end of file control loop. So let's talk about that. Again, this is Dr. Satish Singhal, PhD, Professor Computer Science, El Camino College, Torrance, California. So, schematically, EOF loops looks like this. The file reading header, the device that's going to read your file, software device, is set to first byte in the file. And if file has more than 0 bytes of data and the reading head is on byte number 1, then obviously last byte in the file, after which there is an EOF character has not reached. Okay? So knowing that this condition, while end of file is not reached, will be true because I'm on byte number 1 and end of file is at least after byte number 1 or byte number 2 and so on. So since byte number 1 having a relevant data, end of file is not reached, this condition will be true. And then I read certain number of bytes from the file. Assume I read BT number of bytes. So whatever I read, I'm going to process that. So this step is that BT number of bytes are read and processed. Process could be anything. It could be as simple as taking the same data and outputting that into an output file. That is like just making the copy of the output file. Or it could be more. You could read some numbers, sum them up, find their average, find their standard deviation. Could be anything actually. Okay, so when you have read BT number of bytes and process it, you go past that many bytes. That means end of the file comes closer by BT bytes. So when this process continues on, there will be time, and this BT is not fixed. Like it's not a fixed number. Sometimes you might read 3 bytes, next time you read 10 bytes. It all depends actually what the parsing strategy of the file is. Parsing strategy for the file is a major computer science technology which you will have to learn, and people spend many years learning it. So start paying attention to that now. Anyway, eventually once all the data are read, program has no choice but to read the end of the file character EOF, and then end of the file is reached, so loop exits. So here's the schematic description. Remember I said there are 4 parts to the loop, every loop. So we're going to show where those 4 parts are in EOF loop. They're like this. File reading header is set to first byte, byte number 1, and we have to assume file has more than 0 byte. You're not going to read an empty file. That's the initialization of the loop condition. Loop test is that end of the file is not reached, or another way of saying that is the last byte is not read yet. If that's true, I'm going to enter the loop. I'll read certain number of bytes of data. Again, assume BT bytes were read. I'll process the data. These 2 are the loop tasks. And since I've gone past in the file certain number of bytes, end of file becomes closer by that many bytes, and that's the loop update because loop condition depends upon not reaching end of the file. But when we read certain bytes and we get closer and closer to the end, that means we are updating loop condition in a way that eventually it will reach the end of the file, in which case this condition will be false and will exit the loop. I'll show that to you in a file. Actually, let's take a file and look at it. Okay, take me a couple of minutes to locate it. Okay, so let's look at this file, for example. Oh, actually, this is not a good example. Let's look at this file. Let's say we have this file. So let's say we are reading one line at a time. Parsing strategy for the file is I'm reading one line at a time. So peak function looks at this. That's not ASCII value of this is not -1. It's not EOF. Then I read the entire line and let's say I output it or something. Then so I'll be using getLine for that. Then I read this, look at this character B. Well, that's ASCII value of that is also not -1. So I'm not reached end of the file. So I read this line, and same way I read this line and this line and this line, and finally I read this line up to here. You can't see it, but right here is the EOF character. After reading this, in the next loop iteration, when in.peak looks at this character which is hidden, which you don't see, and there are ways to show that, it will return -1, and EOF itself is a -1. So in that case, this condition will be false. In a minute we'll show you the code for that, and the loop exits. So what will be the code for the file I just showed you, that I want to read that file byte by byte and just output to the another output file. So in a way I'm just making a copy of the file. Okay, that's one of the simple processing. So code for that will look like this. Well, actually, okay, so I'm going to show you, there's more explanation. Code will be in a minute. Yeah, code is here, so we need to go quite a few things before that. Okay, so let's do that. So this process I just showed you in that file, I have exact same file here. So they're just repeating what I just said. Let's say this is the typical picture of file. Byte number A is letter A, and the reading head, which will be ifstream object, will be looking at that. Okay, and peak function, which we are going to discuss in more detail in a minute, will return ASCII value of this, which is not -1. And in each iteration from this file, I'm going to read certain number of bytes. And let's say I'm reading one line each time. So each read advances the reading head, bringing it closer to the EOF. So if I'm reading one line in the first iteration, then I'm closer in number of bytes to this EOF character. And second time reading this, then I'm still more closer. It's read up to here. I'm getting still more closer to this. Read here, still getting closer to this. Read here, still getting closer to this. Read this whole line. Now, in the next read, I'll be right here. Okay? So at that time, loop condition that I read the EOF, loop condition will become false. Okay? So now I've said quite a few times name of the peak function. Let's talk about that. String function peak. The EOF loop condition must detect that character read is not end of file character. Okay, so in previous slide I showed you that in this blue box, but actually in every text file there is a hidden character that's automatically placed in the file, In empty file is right here. As you type, it keeps going, moving towards higher and higher byte value. In this file, I typed up to here, so it's going to be right up. So it's always after the last character you typed. Okay. So this EOF character is embedded in every file, and what it is, it's a constant named EOF. It's a global scope, and it's an integer whose value is -1. So there's a stream function called peak, and it's called with the syntax in.peak, where in is if stream object, or you can do cin.peak when data are entered from the keyboard. And function, as the name suggests, peeks at the next character in the input and returns its copy. So it doesn't go past, it doesn't actually read it. It looks at it and returns its copy, but it doesn't extract it, okay? And it does not go past it. And peek function returns as an integer the ASCII value of character is just read. There's more to peek function. Since ASCII value of all characters is always positive, for all user data, peek will not return a value of -1. Okay, it will always be a positive value. But peek function is designed in such a way that when it reads the EOF character, so where was the EOF character? We just saw that. Last character right after this question mark. I show it big, but it's really just one little thing. Okay, there was no way for me to show it very small. It's just one character, special character. Okay, so when peek function reads EOF character, it is designed to return -1. And if I use a peek condition, loop condition like this, that in.peek is not EOF, EOF is -1, and when peek peeks at EOF character, it returns -1. So -1 not equal to -1 will be false, and that will allow exit from the loop. Okay, we'll describe this one more time when we look at the code. And very simple code for EOF loop will look like this, where we are reading character by character from the file and just outputting it to another file. So in a way, we are just making a copy of the file. So if file has any data, in.peek will return ASCII value of the character it's looking at, it's peeking at. ASCII value of a character can never be negative. EOF is -1. So as long as it saw any character other than the last character in file, this condition will remain true. And then I use a function called get. Again, any function that seems a foreign language to you here, go to c++.com, type the name and look up its detail. But what get function does, it gets just one character and returns it. So ch variable will have the first character. I output it, and the next character again, if it's not EOF, then loop will be entered again, because EOF is -1. ASCII value of character will not be -1. So loop condition will be true. It will read the next character, output that, and this will keep going until in.peek looks at the EOF character, then which has a value -1. -1 not equal to -1 is false, and then we will exit and output ENDR. This will be explained very soon in the Xcode. So let's go to Xcode now. So a lot of code you have seen before, so there's nothing new. I'm just gonna point out what I just did there. So if I look, I already explained in video number 3 how we work with the file. I take the full path to the input file, I do the get line to store it, I declare if stream object in, I open that file whose path was entered here, I do the file opening validation, and so this allows me, gets me ready to read the input file. Reading strategy, which is also called parsing the file, it all depends what is in the file and what you want to do with it. In this case, our goal is very simple. We're going to make copy of the input file into the output file. We just print it to the output file. That's all we're doing, something very simple. But for that, again, we need to do all the steps to open the output file. And we have shown that in video number 3. So again, we have string to store the output file path. We ask user for that. We use getLine to store that. We declare an offstream object. We open the file whose path is stored here. If file doesn't exist, file will be created. That's the characteristic of the output file. If file doesn't exist, it will be created. Otherwise, existing file will be open. I still must do the validation that it is successfully open for writing. And this function will return true if that happened. And now it's the same loop that I showed you before. So in.peek function will peek at the first character. If that has a ASCII value, as it is for any real character, which will not be -1, then it won't be EOF. My loop condition is true. I will go there in the loop. I'll get the first character using in.get, and I output that. And this keeps going until all the characters are read. When EOF, all the characters are read, and last character is EOF, in.peek returns -1. EOF is also -1. And -1 not equal to -1 is false. And I exit the loop, and then I print end of the line. So this code will be uploaded, and you can look at it into more detail. Really, there's nothing new except this code here. Otherwise, this is exactly the last program we did in the video number 3. But this is very important because it tells us how end of file loops, at least one of them, is designed. There are many other ways to design this loop, but this design is the simplest one that I've found in my 20 years of study. So I'm sticking with that. Books have other designs, but to me they're all deficient in one way or the other way. Okay, so we're going to run this program, and we are going to run this where am I? On this file which we showed you earlier, this one, okay? And it has 1, 2, 3, 4, 5, 6 lines. All these 6 lines should be outputted. Where will we output it? We want to output in this file. So let's make this empty and save it. Save. So character by character, this file is read, output it into this file. I want to open into a better quality editor, BB edit, and that's what you see here. Okay, so let's okay, I'm not going to remember. Okay, so as usual, as you know, I would need the full path to the input file. In Mac, I right click, press option, copy full path. Now I'll run my program, and need to see the console. Enter full path to input file. I'll do that. And it'll ask me permission. That's fine. Output file, which I just showed you in a minute ago, could convince you one more time that it's empty. Can you see that? It's empty. There's nothing in there. And it should look like that. But I need to get its full path. Right click, option, copy, and now I'm ready to input it. Sorry. Okay, you'll see no message here because all I'm doing is outputting to the file, so there'll be nothing here. Okay, but now we go to file, output file, this one. There you go. See, input file was this 1, 2, 3, 4, 5, 6 line. Output file is 1, 2, 3, 4, 5, 6 line. First line was quick brown fox jumped over a lazy dog. In the input file, same thing. Quick brown fox jumps over a lazy dog. Last line in input file was did sleepy weather made dog sleepy. Output file last name was did sleepy weather made dog sleepy. So how did this happen? Well, it happens as I described once before. Let me see if I can open two files in different editors and then we'll compare. So this is open in BBEdit, a editor software, and that was my input, and I'll open this one here in our output file here. Okay, so let's put them side by side, and I may have to hover back and forth between my code. So let's go to my code. So when file, okay, so over here in object is looking at letter A, okay, and then let's go to the code. So then in dot peaks at the letter A, returns its ASCII value. Uppercase is 65, EOF is -1. 65 is not equal to -1, that is true. So we enter the loop, and get function then gets A and moves to this white space here. This is very important to know. Get function doesn't skip white spaces. See, in arrow does. Get does not. Get gets all the white spaces as well. So get function gets that and stores that in ch, and then I'm outputting ch. Okay, and basically if I'm able to go at that instant to the output file, A will be outputted at that time. Okay, so then I have to come back to the loop condition because my code lines are finished here. So what does in.peak do now when it has looked at A? It's now looking at the blank space. Blank space also does not have, okay, I should show you in the input file. It's looking at this, peeking at this. This also doesn't have -1 ASCII value. So loop condition again true. Get function gets this space stored into ch, and then I output the blank space, and that's why in output file you see A and then a blank space. Okay, so this process keeps going, and at the end of the line there will be end of line character that's gotten into ch and outputted, and this process keeps on going until this character has been read and output is right over here. Okay, so right here is the EOF character, which you can't see. So then loop condition peak function peaks at that character, returns -1, because that's how peak function is designed, that when it looks at EOF character returns -1. EOF itself has a value of -1. -1 not equal to -1 is false, and I exit the loop and I print out ENTR. So that's my program, simplest possible program to explain how EOF loop works. This is one way to design EOF loop. There are several other ways. You can investigate them yourself. To me, this is the simplest. So I'm going to stick with this. So that will do for this video. Thankfully a shorter video after many long ones. So this is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, saying goodbye from looping video number 4, and hope to see you very soon in 5, 6, and so on. Thank you.